Okay, we are going to derive some fundamental identities in trig. We're going to start off with the idea that we know the sine of an angle is equivalent to the y coordinate on the unit circle, and cosine of an angle is equivalent to the x coordinate on that unit circle when that angle t sweeps out. So we're going to go back and look at tangent. We know that tangent is the y coordinate divided by the x. Since we know that y is equivalent to sine of the angle, and x is equivalent to the cosine of the angle, I can say that sine of the angle over cosine of the angle, if I take these two quantities and divide them, that's the same thing as tangent of that angle. So here's one very important identity that we'll use quite a bit. Now, because cotangent is the reciprocal of tangent, we can go ahead then and say that cotangent is cosine of the angle over sine of the angle, which is the reciprocal of tangent. So there's a second identity that's really important and we'll use quite often. We also know that cosecant of the angle is the reciprocal of sine, which is 1 over y. And since y is sine, we can say that cosecant of the angle is equal to 1 over sine of that angle. So there's another fundamental identity. And the last one is secant. I know that secant is equivalent to 1 over x, and since x is cosine of that angle, I can write it as 1 over cosine t. That's equivalent to secant t. So there is the last fundamental identity. Now we're going to use that to find some exact values given some information. So for part A of this example, we're given that we know that the sine of 45 is the square root of 2 over 2, the cosine of 45 is the square root of 2 over 2, and we're going to use that information to evaluate tangent of 45. So tangent of 45 degrees, using our fundamental identity, I know tangent of 45 is the same as saying sine of 45 degrees divided by cosine of 45 degrees. They give us in the problem that sine of 45 degrees is the square root of 2 over 2 and cosine of 45 degrees is the square root of 2 over 2. So I'm going to plug that in. So we know that if we have a fraction and the numerator is equivalent to the denominator, if it's the same thing on the top and the bottom, that's equal to 1. So we can say that the tangent of 45 is equal to 1. That was part A. Part B, we're given that the sine of 5 pi over 6 is equal to 1/2. The cosine of 5 pi over 6 is equal to negative square root of 3 over 2. And we're going to evaluate the secant of 5 pi over 6. I know that secant, using my fundamental identity, is the reciprocal of cosine. So the cosine of 5 pi over 6 is what I'm going to put in the denominator here. I'm going to take 1 over cosine of 5 pi over 6. That is the same thing as secant of 5 pi over 6. Since the problem gives us that cosine of 5 pi over 6 is negative square root of 3 over 2, I'm going to plug that in. So 1 over negative the square root of 3 over 2. When I divide, I take 1 divided by negative square root of 3 over 2. I do a flip and multiply, and I get negative 2 over the square root of 3. And then if you want to rationalize it, you can. So the secant of 5 pi over 6 is negative 2 over the square root of 3. Now, if I had a part C to that, and I ask you to find, using information from part B, okay, let's say I ask you to find the cosecant of 5 pi over 6. The cosecant of 5 pi over 6 is equivalent to 1 over sine of 5 pi over 6. The fundamental identity for cosecant is 1 over sine. So, since the problem in part B, we're using the information from part B, they give us that the sine of 5 pi over 6 is a half. So I'm going to have 1 over, and then sine of 5 pi over 6 is a half. When I do my flip and multiply, I get 1 divided by 1/2. That's 2. So the cosecant of 5 pi over 6 would be 2.